Let's take a look at the sum of the natural numbers. And let's define natural numbers as integers, that is positive whole numbers, including 0. And of course we can add 0 onto these sums and the answer wouldn't alter. Sum is just a posh word for addition. Okay, so there's an easier way to write these, and we can write them using something called sigma notation. This is sigma. It's a letter of the Greek alphabet, and it means add or sum. Okay, so instead of writing these out, which is very time consuming, we can just use sigma notation. So for example, let's do 10. We can sum from 1 to 4 I. And the general formula is we go from 1 to n I. Okay, so let's do another one. Let's do 7. So we go in from 1 to 7 I. Okay, so pause the video and see if you can write the rest of the sigma notation. Okay, so hopefully you've done that now. I'm not going to do them all. Let's do going from 1 to 3. We use I. Let's do this one. 1 to 5 I. And let's go I 1 to 9. Just a quick note about this. This is a variable, and it takes different values lower than n. The I is commonly used. I don't know why, but we could use any other letter in the alphabet. Now, this problem was posed to me by a Year 7 student, and we were doing the sum of the first 10 natural numbers, the sum of the first 10 cube numbers, and some of the first 10 square numbers. And I was asked a question, and the question was, isn't there an easier way of working these sums out? And I said, yes, there is. There's a formula you can use for the sum of the first natural numbers, some of the first square natural numbers, and the sum of the first cube natural numbers. And the formula is this. We sum, going from 1 to n, I, and the formula is n plus 1 divided by 2. And we use this formula quite a bit in maths. We prove the formula for the natural numbers, natural square numbers, and the natural cube numbers. We prove that it's true, but we don't look at how to derive the formula or where it comes from. And I'm just going to do that now. Let's consider the sum of the first 6 natural numbers. Okay, so let's redo that. Okay, so we've got the sum of the first 6 natural numbers: 1 plus 2 plus 3 plus 4 plus 5 plus 6. And let's group the first and the last, the second and the penultimate ones, and the two middle ones. Now, if you remember, the formula we want to show is n plus 1, all divided by 2. And from the previous slide, we know that the sum of the first 6 natural numbers is 21. Okay, so if we add each of the paired numbers, we get 7, 7, 7. Okay, so I think you can recognize that 7 is n plus 1. Here, n is equal to 6. n plus 1, therefore, is 7. We have a 7 here, here, here. Now we need to get n. Well, let's look at what we need to multiply 7 by to get to 21. That's going to be 3. So that's where the n divided by 2 value comes from. And let's do that more explicitly on the right hand side. So we've got 3 multiplied by 7 is equal to 21. Now the 3 is the n divided by 2, and the 7 is the n plus 1. If we multiply those together, we get n plus 1 all over 2. Now, let's have a look at a bigger number. Let's have a look at a bigger sum, rather. Let's do 10. Okay, so we've got 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay, let's use the same method. Let's group the first and the last, second and the Okay, if we add them up, we get 11. 9 plus 2 is 11. 8 plus 3 is 11. 7 plus 4 is 11. 5 plus 6 is 11. Now, we know from the previous slide, the first slide, that this sum adds together to give 55. And let's put that at the top and keep that in our minds. Okay, so we need to get to 55. Now, we've already got 11. What do we multiply 11 by to get to 55? That is 5. Now, I hope you can recognize here n is equal to 10. The 11 is n plus 1. The 5 is the n divided by 2. And if we multiply these two, we get n plus 1 all over 2. Okay, now we've looked at 10 and 6. Now 10 and 6 are both even numbers. What would happen if we looked at an odd number? Let's look at an odd number. Let's look at the sum of the first 5 natural numbers. Okay, so let's do that then. 1 plus 2 plus 3 plus 4 plus 5. Okay, so let's group them the same as last time. Okay, now we know from the previous slide, or you can work it out, that the sum of the first 5 natural numbers is 15. We got n is equal to 5. Again, let's add these sums up. We've got 6, 6, and then we've got 3 in the middle. So we need to get to 15. I hope you can see that we're going to get 3 multiplied by 5. Now the 5 is our n value. We get the 3 from doing n plus 1 all divided by 2. The 3 here is calculated slightly differently. Here we add 1 to the n value, which is 5. 5 plus 1 is 6. Then we divide by 2 to get to 3. And our formula is n plus 1 all divided by 2. And we can show that this works. Let's write the full one at this time. 1 to n to I is n plus 1 all over 2. Let's apply this formula then. We're going up to 5. Come from 1, I is 5 multiplied by 6 divided by 2. 5 6 is 30 divided by 2 is 15. Okay, so let's try some more complicated examples. Let's try 3 examples. Okay, so 1, 2, 3. I would like you to go from 1 to 20, 1 to 50, and 1 to 100. Okay, so pause the video and see if you can do these. Okay, so hopefully you've done that now. So I would encourage you to write down the formula until you are proficient at answering these questions. So the formula was n plus 1 all divided by 2. So n here is 20, so we got 20 multiplied by 21 divided by 2. So on your calculator, 20 multiplied by 21 divided by 2 is 210. Here we have 50 multiplied by 51 divided by 2. On our calculators, 50 multiplied by 51 divided by 2 is 1275. Here we got 100 multiplied by 101 divided by 2 gives us 100 multiplied by 101 divided by 2 gives us 5050. Finding out where a formula comes from and the derivation gives us some insight into the maths behind the formula, and it gives us a greater understanding. This is not a rigorous proof. This is just showing how the formula comes about, and hopefully you're able to use and apply this formula in your number theory.